Session layer. The session layer opens dialogue between the sender and receiver. It also continuously monitors conversations and makes sure that everyone is getting along. The session layer does all this by using three simple steps. 1. Connection establishment. Second, data transfer. And third is connection release. Connection establishment. During connection establishment, the sender and receiver recognize each other and agrees to communicate. Connection establishment includes all the subtasks necessary to get things going. These subtasks include 1. Verifying user login names and passwords. Second, establishing connection ID numbers. This function relies on the transport layer to identify the correct service addresses. Third, agreeing on which services are required and for what duration. This usually occurs early in the conversation. Fourth is determining which entity will begin the conversation. And fifth is coordinating acknowledgement, numbering, and retransmission procedures. This is session layer error checking. In OSI layer, error checking takes place at three layers: data link layer, transport layer, and session layer. Data link layer is concerned with what's in the packet and whether it has arrived uncorrupted or how. The transport layer tracks the route the packet takes and makes sure it arrives at correct destination. Finally, session layer maintains the lines of communication and ensures the reliable conversation. The error checking procedure begins during connection establishment and is maintained throughout entire conversation. Data transfer. Once connection is established, the actual data transfer takes place. Data transfer tasks manage session layer messages and ensure productive conversations. Data transfer occurs through a specific dialogue, which is an established connection between two network entities currently engaged in data transfer. Data transfer occurs in three ways: 1. Simplex, second half duplex, and third is full duplex. Simplex. Here, one device is allowed to transmit and all other receive. With simplex conversations, the channel's full bandwidth is always available for signals traveling from the sender to the receiver. On the simplex channel, transmitting device cannot receive information and receiving device cannot transmit. Simplex data transmission have many more advantages, but since they allows one-way communications, it severely limits data communications applications of simplex dialog. Commercial broadcast radio and television stations are most popular simplex conversations. Half duplex. In half duplex, each device can transmit and receive, but not at the same time. With half duplex conversations, the channel's full bandwidth is available to the transmitting device, but it can't receive while it's transmitting. On the upside, half duplex dialogues require only one channel for both transmission and reception, and they support bidirectional communications. Unfortunately, only one unit can transmit at a time, and the hardware is relatively more expensive. Also, the channel is not used efficiently during direction changes. Full duplex. Full duplex communications allow every device to transmit and receive at the same time. Many full duplex systems require every device to have two transmission channels, one for transmit and one for receive. An excellent example of full duplex dialog is telephone. In addition to dialog control and data transfer, session layer at this stage performs two reliability tasks: acknowledgement and resumption. In coordination with the data link layer, the session layer is responsible for acknowledgements during data transfer. This reliability feature ensures that lower layer protocols keep track of which messages belong to which upper layer services. In addition, part of the session layer's error checking algorithm calls for the resumption of interrupted communications. Connection release. After data transfer is complete, the connection must be released to make room for future conversations. This process can be planned or accidental. Planned connection release usually is accomplished by agreement between the two systems, similar to both parties saying goodbye to end a telephone conversation. Accidental connection release usually is caused by loss of connection. In such cases, lower layer protocols recognize a loss of connection when they do not receive the acknowledgement they expect. It is their responsibility to inform the session layer that connection has been lost. In this case, session layer error checking resumes the interrupted dialog and restarts the communication using a new conversation. Either way, accidental connection release is resolved by the session layer. This completes our functional overview of session layer.